Hello there, I'm Pooja. Welcome back to Periodic Chemistry. At the end of this video, we will be able to solve numericals that come under galvanic cell. If you're new to my channel and haven't subscribed yet, please subscribe and hit the bell icon to get notified whenever I come up with new videos. Let's start. Let's first understand what are electrode potentials. According to the definition, potential difference established due to electrode half reaction occurring at electrode surface is electrode potential. In simple words, we can define it as a tendency of an electrode to undergo oxidation or reduction reaction. That means every particular electrode or the reaction is going to have its unique and own electrode potential, which will decide whether it will undergo oxidation reaction or reduction reaction. Now let's see the formulas that will be needed to solve the numericals. First one is for cell potential. E cell, which is equal to E reduction of cathode minus E reduction of anode. That means E reduction of cathode and E reduction of anode are the electrode potentials, while the cell potential is going to be difference between these two electrode potentials. Another formula is E naught cell is equal to E naught reduction of cathode minus E naught reduction of anode. Here E naught reduction are nothing but the standard cell potentials and standard reduction potentials. Standard reduction potentials are those which are measured at standard conditions. What are those standard conditions? When the concentration is 1 molar, pressure is 1 atmosphere and temperature is 25 degrees Celsius, then that potential is said to be standard potential or standard electrode potential. There are various forms of these formulas given in the textbook, but we will be remembering just cathode minus anode to avoid the confusions. And remember that whenever we are using cathode minus anode, the potentials are going to be the reduction potentials. Now let's see another formula, that is E naught reduction of cathode is greater than E naught reduction of anode. So this is going to be always true, that cathode is always going to be greater than the anode. Now what if we are given oxidation potentials? When oxidation potentials are given, we can convert those into reduction potential because the relation between them is E naught reduction is equal to negative E naught oxidation. That means they both are equal and opposite. So these were all formulas that will be needed to solve the numericals that come under galvanic cell. Let's start solving the numericals. Let's solve 6th MCQ from Maharashtra State Board 12th Standard Science textbook. Here 4 reactions are given along with their standard potentials, and we need to determine the strongest oxidizing and reducing agent. How will you decide whether the given potential is a standard oxidation potential or a standard reduction potential? Yes, from the reactions, we can say that electrons are to the left hand side in all the reactions. That means gain of electrons is happening in all the reactions, and therefore gain of reaction is a reduction reaction, and hence the given potentials are the standard reduction potentials. You can also remember that whenever it is not mentioned whether it is an oxidation potential or a reduction potential, we have to assume that the given potentials are standard reduction potentials. Now let's see step-by-step solution for this example. Given terms are the reactions and the reduction potentials. First, we need to determine the highest and the lowest reduction potential. It's clear that reduction potential for silver, that is Ag, is the highest, which is 0.8 volts, while reduction potential for Fe, that is iron, is the lowest, which is minus 0.44 volts. Remember that whenever we have a negative sign, the number with the highest magnitude will have the lowest value. Now let's see the approach to solve this problem. We need to remember this line that higher positive reduction potential means reduction reaction. That means any reaction having high positive reduction potential has a tendency to undergo reduction reaction, and these agents which undergo reduction reaction are strong oxidizing agent. Therefore, we can summarize it as The agent which itself undergo oxidation reaction will be a strong reducing agent, and agent itself undergoing reduction reaction will be a strong oxidizing agent, and the reaction having a higher positive reduction potentials will undergo reduction reaction. Similarly, we can write that lower reduction potential means oxidation reaction. That means the reactions having lower reduction potentials has a tendency to undergo itself oxidation reaction, and therefore that reagent will be a strong reducing agent. So from all these steps, we can clearly tell that Ag plus is a strong oxidizing agent because it has a highest electrode potential, while Fe is a strong reducing agent because it has a lowest reduction potential. We can see two options A and B where Ag and Fe are included. But reagents are nothing but those which are to the left hand side. So we need to see the reactions in which this Ag plus is to the left hand side and Fe is to the left hand side. And therefore correct option will be B, that is Ag plus, and Fe, that is iron. An important application of standard reduction potentials is to determine the spontaneity of the reaction. We can see this clearly in 14th question under question number 4. Here we need to determine whether the reactions are going to occur spontaneously or not under the standard states. Let's first solve for A part. Approach for this will be when E0 cell is positive, that time the reaction is going to be a spontaneous reaction. So first we will write the reaction given as it is. Calcium plus cadmium plus 2 ions giving cadmium plus 2 plus cadmium solid. E0 reduction of cadmium is minus 0.403 volts, and for calcium it is minus 2.866 volts. I have taken this data from the electrochemical series, but don't worry, this data will be provided in the exam. Now we need to see which is the greatest electrode potential. Yes, cadmium has an highest reduction potential, and therefore we will be using cadmium as an cathode electrode and calcium as an anode electrode, because we have seen in my previous slides that electrode potential of cathode is always greater than the anode. So this is how we can decide the cathode electrode and the anode electrode. Now we will be using the formula for E0 cell to find the standard cell potential. Yes, so E0 cell is equal to E0 reduction of cathode minus E0 reduction of anode. By plugging the values in the equation, we get minus 0.403 minus 2.866. After calculating, we get our final answer as plus 2.463 volts. So the standard cell potential for this reaction is plus 2.463 volts, and therefore this reaction is going to occur spontaneously. We have seen about spontaneity and the meaning of spontaneous reactions in my very first video. Now let's see for part C. The reaction given is 2 silver plus Ni plus 2 ions giving 2 silver plus 2 ions plus Ni solid, that is nickel. We will follow the same steps. First we will write the reduction potential of each. For nickel it is minus 0.27 volts, and for silver it is 0.799 volts. Reduction potential of silver being higher, we will be using it as a cathode electrode, while nickel will be an anode electrode. Plugging the values in the respective positions, we get E0 cell as 0.799 volt minus 0.257, which will give plus 1.056 volt as our final answer. Here also we have got the E0 cell as positive, and therefore the reaction is going to occur spontaneously. To make it more clear, let's solve part B. 2 Br minus ions plus Sn plus 2 ions giving Br to liquid plus Sn solid. Sn is a symbol for tin. Again I will write the standard reduction potentials for each. Here the standard reduction potential for Br is greater than Sn, and therefore it's clear that Br is going to be an cathode electrode while Sn is going to be an anode electrode. And therefore, plugging the values in the equation and calculating, we get plus 1.216 as a standard potential, cell potential of this reaction. And again, this reaction turns out to be spontaneous. So this is a very important application of standard reduction potentials or the standard cell potentials, because we can determine whether the reaction is going to occur spontaneously or not before even performing the experiment. So we can make a right choice of the electrodes, that is cathode and anode, and make our reactions occur spontaneously. Alright, so this was all about this part of electrochemistry. For further concepts, you can watch my other videos and my previous ones. Guys, please give your feedback so that I can improve myself and I can come up with new videos like this. Don't forget to hit the bell icon, like, share, subscribe, and comment. Till then, thank you and stay safe.